This video is recorded to help my students to understand how to write functions and how to write manual to test functions. Let's suppose we have the following three functions needed to write. One is bool is leap year, which take an integer year as an input. Return true if the given year is a leap year, false otherwise. Another function is get month value, which take input by month and a year. The month will input as an integer from 1 to 12 inclusive. 1 means January, 2 means February, and so on. The post condition is the return value is based on the following table. For January, will return 0. If that year is leap year, January will return 6. February, it returns 3, and if that year is leap year, will return 2. Then March, the return value is 3, no matter what year it is. April is 6, May is 1, June is 4, July is 6, August is 2, September is 5, and October is 0, November 3, December 5. These two functions is leap year and get month value are two functions the students need to write in their project 5. Now I give two more actual functions. One is integer sum, integer n. This function takes n as the input, where n is a positive integer, and return the sum of 1 plus 2 plus 3 plus up to n. Another is non-integer factorial, which take an integer as input, n is non-negative integer, and the return value depends on n. If n is 0, then returns 1. Otherwise, return the product of 1 multiplied 2 multiplied up to n. I will use these four functions as example to show how to write functions and how to write a manual to test the function you write. Okay, first let us structure this program. To save time, I will just copy those function declaration, and to save time, I don't copy any comments. I declare the functions, but I don't copy those function commands, okay? But the student, when you write the program, you should have good habit, have all those commands, which is the documentation for those functions, precondition and post-condition you must write. Okay, now let's see. In the main function, I will write code in the main function. Basically, do first display menu. This menu will ask a user to choose which function he wanted to test. Based on the choice, then the program will ask a user to input the data for that function, then do the test. So in that case, we need to have another actual function called menu. This function displays the menu for user to choose. Okay. Now, suppose this function and menu like a test is leap year function, test get month value function, test sum function, test factorial function, then exit. So you have 5 menu options. We should know how to write this kind of function. For example, you can write it as this way. Cout then you have menu. Remember, cout just print out whatever you type here. So option 1, test is leap year. This function, then cout Option 2, test get month's value. Okay, test this function. Then see out option 3, test sum function. Then see out option 4, test factorial function. Then see out option 5, quit. So the main function will display this menu, ask a user to choose. Based on user's choice, then the main function will get appropriate input, then call the function, it will test it, then display the result. Okay. So if you want, you can put another sentence here. Please enter your choice. Well, remember, for each line, I will print out a new line. So one thing we can do is print out a new line. Right? I will print out a new line after each line. So my menu will be exactly as what I will display here. Okay. Then I will print out enter your choice. Well, you don't have to put it here. Some students like to put it here and say menu is enter your choice. But probably we don't do this. We use menu just simply display the menu. Okay. Now, in the main function, what I will do, I will do the test, right? Like I do, well, the choice not equal 5. As long as user's choice is not equal 5. Okay. Now, if user's choice, then we need to have an integer choice. You can use choice as integer. So in this do while loop, the first thing I call menu function to display the menu. Then after display menu, I print out a message, enter your choice. Then we get a user's choice. Then switch user's choice. Now, how many cases we have? If it's case 1, which means I will test is deeply a function. I write down the structure first, okay? The code I will fill in late. Test 2, option 2, then test get month's value function. Then break case 3. This in the case 3, I will test sum function. Then break. Then case 4, I will test factorial function. Then break. Then case 5, this will be quit. How do we quit? Quit will probably just print out some error message, thank you message, thanks for using the function tester program. But you just print out any message to quit. Okay, then default. Default, you print out a message, run choice. Please choose from menu. Break. Now, look at this main function. choice I spelled wrong. Look at this main function. Main function will repeatedly do the following thing. Do what? First, display the menu. Then ask a user enter his or her choice. Then get user's choice. Right? This is first display menu. Then get user's choice. Then based on user's choice, your code, if user choose 1, then your code will be test is leap year function. If user choose 2, your code will test get month value function. Notice those tests will go through in this way. You ask a user give an input, then print out the result. For example, if a test is leap year, I give year 2012. I know that is a leap year. If it print out say it's not a leap year, then you know it's leap year function you did wrong. If it's print out say it is a leap year, then it seems like okay. Then you can test more. You use more year as input data to test its leap year function. Okay, so that's how it goes. Now pay attention. At this point, you should be able to successfully compile your program, but you might not be able to run your program. Okay? So in order the program can be compiled under kind of run, even don't have good result, you will be able to link. You should implement all those functions. Now we only implement the menu function. How to implement other functions? Well, the good habit is you can implement one by one. But for the rest of function, you just write it as a stub. What is stub? It's a very simple implemented function that didn't really do anything, just for compile or link purpose. For example, is leap year function. This function return true or false is leap year. You give me an integer year, right? Then this function, I just say return true. Now, if I implement that like this, I mean every year is leap year, of course it's wrong implementation. However, when you try to compile it or you try to link it, it will work. So we call this kind of implementation called stub implementation, just for compile purpose. If we make every other function become stable and implement one single function completely, then you can run the program test that single function. So now that's the second function called integer get month value. You give me a month, you give me a year, I will return this month value. Since this function return an integer, so I can always just say return 0. This called implement is a stable function. Then integer sum, integer n. Since this function return an integer, so I also can just return a 0 first. Then the function non-integer factorial integer n. Then this function I just can simply return 0, 2. Now at this point, I should be able to run and compile my program, but here is something wrong. Return spelled wrong. Return. Okay. Now everything is fine. Now if you wish, you can run the program. You see the result. Enter your choice. Now you can test. You enter 1. It's running. Enter 6. Use let us see the result. Enter 1. You do nothing because we didn't enter anything. Enter 6. Run choice. Please choose from menu. If I enter 5, then quit. Thanks for using the function testing program. Then the program quit. Okay. Now, so at this point, I know my program structure is good, and the program can be compiled, can run, even if it didn't do anything. Now I begin to write all those tests. How can I test is leap year? Well, I can do this. Cout into a year. Well, in that case, I need to have a variable called year, right? You can call something else integer year, the same year. Okay. Now then I say if is leap year, see out the year, print out this year is a leap year. Else, see out the year is not a leap year. Okay, so this code, if I implement is leap year function, then I ask a user enter a year, then I call is leap year function, then this code will return, will print out the year, whatever year is a leap year, if this is leap year function return true. Now this really can help you to determine if your is leap year function work correctly or not. For example, if you enter the year 2012, we know it is a leap year. However, if your program print out say the year 2012 is not a leap year, then you know is leap year function implemented wrong. Okay. Now you do not have to implement all other cases before you can test is leap year function. You actually can test it now. You test it now is because you just want to simply say if you call is leap year function correctly or not. If your program can run, and since your is leap year function now always return true, then your program supposed to print out no matter what year you input, say the year is a leap year. Let us try. Successfully, then choose option 1, enter a year. For example, I enter year 2011. I know it's not a leap year, but since I did not really implement my is leap year function yet, I just implemented it as stable. It's always return true. So this will say 2011 is a leap year, right? Okay, now we quit. Now, what I'm going to do is I'm going to implement is leap year. How do you decide if the year is a leap year? According to your textbook, it gives you a formula. A year is a leap year if this year is divided by 4, but not divisible by 100, or it is divisible by 400. So you will return is this year is divisible by 4. That means module 4 equals 0. Divided by 4, remainder is 0. And the year divided by 100 is not a 0. Or this year divided by 400, remainder is 0. So now let us test again. Successful. So if this implementation is right, first I choose. Now test the year 2011 again. It's not a leap year, okay? Let us test 2012. It is a leap year, okay? Let us test 1900. We know year 1900 suppose not a leap year. Year 1900 is not a leap year. Then I test year 2000 supposed to be a leap year. Yes, 2000 is leap year. So my leap year function work correctly. Okay, so I finish test 1. Now I implement the next function. Next function get a month value function. So you will say out into a month and a year. Separate by white space. You ask a user enter two values, separate them by white space. So you enter month, then you enter year. Get a month, get a year. But now you notice the month is not declared. So you can go back here, declare the month, variable month. Then you go back here to, after you get the input, you then print out the message, see out the month value is get month value. Now they will give you months, so the months will be months, and the year you will print out this. Then you might want to print out the new line. Okay. Now to test this part, you need to test all the cases you can think of. Like look at this table. So you will input a month as 1, which is January. What a year is a leap year or not a leap year. Is a leap year return 6, another leap year return 0. Basically, you need to test over all those cases. Now, then how to write this function? Get a month value. Now, this get a month value, we can say you can say integer result equal -1. Since -1 cannot be a return value, so I initialize it first as -1. Then I will switch the months. Since I have 12 months, all this 12 months case, he already the function's post condition already specify what will be the output. So I just do this way. Okay. Now, if you want to save time, you must say put a sum together, like September and December, they're all 5. So you can say case 9, case 12, the return value is 5. You can do that way if you wish to. But in order to make it more readable, you probably just want to say case 1, you know that's January. Now January, if is leap year, the year, given year is leap year, then the result will be equal 6, else the result will be equal 0, then break. That is exactly in here say if January 6 if it's a leap year, 0 if it's not a leap year. Okay, so let us try to say February 3 and 2. Okay, so case 2, February, if is leap year, then result will equal 3, else result equal 2. I hope I remember right. Let me go up, double check. If is leap year is 3, no, if is leap year is 2, otherwise it's 3. So if it's leap year is 2, otherwise it will be 3. Okay, let's say what about March? Probably let me copy this down to make it simple, so I don't have to go up. Look, so now, so March is case 3. March will return value is 3. So case 3 result equals 3. Break. Now the case 4, which is April, result equals 6. Then break. Then case 5, May, the result equal 1. Break. What I'm doing. Okay, then June, case 6, The result is 4, break, then case 7, July, the result is 6, break, case 8, result equal 2, then break, then case 9, result equal 5, then break, then case 10, result equals 0, then break. I use switch is very readable, so you can see the 12 months very clear. Each month, what is the month value? Case 11, result equals 3, then break, then finally I have case 12, result equals 5, then break. Now I just simply return result. Okay. Here I miss semicolon here, so I put. Now you see this is implementation very simple. I just implement according to the post condition, actually according to the table, right? You give to me. Said each month, what is the month value? For January, if the year is leap year, then the month value is 6, otherwise the month value is 0. So for the February, if the year is leap year, the month value is 2, otherwise is 3. Then for other months has nothing to do with year. So you just simply implement the idea. For each case, which you switch the months. For each case, you assign result a value according to the post condition. Finally, you return this result. Now, pay attention here is, how about if none of the case happen? Well, then because people use your function wrong, because in your function precondition, you already restricted the months have to be integer value from 1 to 3 up to 12. Okay, so if the guy use your function did not fulfill this precondition, that's not your fault. So you already tell them this month is the actual month. 1 means January, 2 means February, and so on. So after you did this function, then you can run your program to test this function. Now, you click here. Now I want to test this function. I test option 2. Ask you enter month and year. Suppose I enter January 2012, which is a leap year. So suppose return 6. So the month value is 6. That's correct. Now I test again 2. Enter a month and a year. Suppose this time I enter February and 1999, which is not a leap year. I believe is not a leap year, supposed to return you 3. Is that right? Yeah, the month value is 3. Okay, you can go over all the cases to test if your get month value function is correct or not. Well, we don't waste time here. We just quit. Okay. Now, we already finished 2 functions. Then next, let's do rather than test sum function. Test sum, of course, there was a cout into an integer, and saying n. Now we didn't declare n yet, so we can declare n if you wish. You also can declare n just here, okay? Because C++ you can declare variable when you need it. Just make sure the variable scope is correct. Okay, now I want the way I want to test this sum function is after you give me an integer, I call the sum function. Then I check if it's really calculated 1 plus 2 plus up to n. So the cout 1 plus 2 plus up to n is, now then I print out sum n. I say if this is correct. Of course, I might want to print out a new line. Now, how to test this? Because we know some result, like for example, we know from 1 plus 2 plus up to 100 is 5050. If the result didn't print out 5050, that means your function is not correct. Another thing is we know 1 plus 2 plus up to 5 will give you 15. If you enter n as 5, the result is not, say, 15, then your sum function is not correct. Okay, so now let us test this sum function. Of course, at the beginning, you can try to say if you call the sum function right or not. You can go to do this. Then you choose option 3, test the sum function. You just simply test to see if you call it right. Now you remember your sum function you have not implemented yet. So no matter what integer you gave, the sum will always be 0 because you implement it as a stub, always return 0. So they say the sum is 0. Of course, that's not correct. But at least we know in your main function, when you test the sum function, you call the function correctly. This really call the sum function. Okay, now we quit and go back to implement the sum function. Now, implement the sum function, of course, we can always declare a result equals 0. Then for integer I equals 1, I less than equal to n, I plus plus. That means I step through 1, 2, 3, 4 up to n. Every time my result equal result plus I. That means every time I add I to the result, then finally I return result. Now let's quickly go through this function. I first initialize the result is 0. Then I step through 1, 2, 3 up to n. Each iteration I add the I to the result. So when I equal 1, you add 1 to result. When I equal 2, you add 2 to the result. So after you step through 1, 2, 3 up to n, you actually add 1, 2, 3 up to n to the result. So your result will be 1 plus 2 plus 3 plus up to n. Okay? Now, let us test this, see if it is okay. So you run the program. Then you choose option 3, right? Then you want to test it. For example, 100 suppose give you 5050. Yeah. Okay, I test again. 5 suppose give you 15. Yes. So it seems like okay. So I quit. Then I into the last one. Last one, I declare the return type is a non-integer because factorial will go big very fast. What is a factorial? Factorial is n multiply n minus 1 multiply n minus 2 multiply until to 1 go down. So that's factorial. This number is very huge when n a little bit bigger. Okay, and there is a special case when n equals 0, the factorial of n is 1. So we can do this way. We say if n is 0, then I just return 1. So when n is 0, or we just say mathematically we define 0 factorial, this notation of factorial equal 1. Now, if I don't return, then I can declare non-integer result equal 1. I declare the result equal 1 first. Okay. Then I still use a for loop. For integer I equal n, I greater than 1, I minus minus. What I do? Every time my result equal result multiply I. So first I multiply n to the result is n, then I reduce by 1, I is n minus 1. Then I multiply n minus 1 to the result, then I multiply n minus 2 to the result. Equivalent of my result is n multiply n minus 1 multiply n minus 2. I do not need multiply 1 because anything multiply 1 is itself, so I can say just I greater than 1. Of course, if you change I greater than or equal to 1 here, it's okay. So finally, I return result. Okay. Now, again, I can test this factorial function by cout. Ask people integer, then cin, n. Now cout 1 multiply 2 multiply n equal, which is this factorial. I call the function factorial n. Okay. Now then I use some value to test. We know the 5 factorial is 120. I can test that, see if it works. For example, I choose option 4. Let me make this bigger. I choose option 4. Then I input 5. Yeah, 5 factorial. Oh, somehow here did not print out 5. So I should say 1 multiply 2 multiply up to 5 equal 120. So let's quit, debug, see what we did wrong here. Oh, okay, here is the reason. So I should not input n. I should not put n in the double quote marks because that's what just print out it as n. I want to print out it as n's variable n's value. So now we should fix the problem. Let's run again. I test 4. Okay. Then I will enter integer 5. 1 multiply 2 multiply up to 5 is 120. Then I quit. Now, let's see here. You need to understand you can implement all those first. Okay? You can implement all those main function switch statement first. Then you implement every function as a stubble, which means you don't you just for the compile link purpose, you implement the function in the most simplest version. It might not be right, but it can be compiled, can be linked. So then you can call those functions to make sure your switch statement in each case it call the function correctly. After that, then you can begin implement the function one by one. Every time you implement one function, you run the program, you only choose that menu option to test the function you just implemented. In this case, you by this method, you can test all the functions. Now, this example is similar to your project 5, but not exactly the same. The student still need to understand how to write a project 5. If you have any questions, please give me an email.